that, but we have the fingerprint, and when we analyzed the soil and the sediment, it actually matched. You could lay one over the other, and they matched. So it was BP crude we were analyzing. And then the oil range organics, there was as much as 1.16% oil range organics, which is a huge, huge quantity of oil range organics in these samples. So then 60% of those soil and sediment that we sampled all along from Atchafalaya Bay to the Mississippi state line had up to 18 PAHs in excess of what's called the marine sediment screening level. That's a national marine sediment screening level established at the national level, and 60% of those soils and sediments exceeded. You will hear a lot of presentations that say, it's all gone, nothing's out there, nothing's left. Well, when we were doing the sampling all along that time period, we found up to 60% of them had in excess of the marine screening levels. And all of the areas that we sampled that had soil and sediment, all of those areas were contaminated with the alkylated PAHs and the oil range organic. So let's look at the aquatic tissue. First, let's look at shrimp. Oil range organics, right under 1% oil range organics. Anthracene, chloranthrene, naphthalene, pyrene, these are PAHs. And I have them listed here, but I want you to start listening to the names, because you're going to hear those names over and over again as I talk, as John talks, as we move forward in the GC-HARMS process. Especially the naphthalene is suspected to cause cancer in humans, and we found it in the shrimp. Then we did blue crabs. Oil range organics, a little less than 0.5% oil range organics in the blue crabs. And up to 4 of the alkylated PAHs, you see a concentration up to 162 micrograms per kilogram. But you see the same names again: chloranthrene, naphthalene, pyrene. So moving to the oysters, oil range organics, 1.25% oil range organics. These oysters were not visibly oiled. They looked like the oysters if you were out on the boat, you pulled them in, you'd open them up and eat them right there. They looked that good. They were not visibly oiled, and yet they had a huge amount. Can you get rid of this? Now we're running on reserve battery power. One moment while we plug it in. So again, these oysters had 1.25% oil range organics and 4 other PAHs. And then we collected mussel samples. So we collected whatever we found out there. John will not be doing mussels in the GC-HARMS project, but again, the oil range organics were just under 0.7%. And now you have a 2-methyl naphthalene, you see. We didn't see that in some of the others. So some of the different organisms pull things in. The oysters are filter feeders, the mussels are digging into the soil, and so you start picking up, but once again, you see the naphthalene in the mussel samples. This is Paul, or who's not with us tonight, and he's collecting oysters from the Lake Borne area of St. Bernard Parish. See the blue gloves? You put on the gloves so you protect the sample as well as you protect yourself from contaminating the sample, so you're sure that the sample you're collecting does not come from something you had on your hands. So we look at the polynuclear aromatic hydrocarbons in the tissue samples from St. Bernard. Shrimp from southwest shoreline of Pearl River Island, phenanthrene. Oysters from the eastern shore of Lake Borne, just off the shell nib. And you see there are 4 polynuclear aromatic hydrocarbons. Once again, the naphthalene and the pyrene and the phenanthrene. Some from southern leeward side of Half Moon Island, naphthalene. West Peoria Bay, naphthalene. The crabs from St. Bernard. southwest, leeward side, half moon island, naphthalene. So you start seeing a pattern in the different types of tissue samples we collected. And I can't tell if this is you, Michael, or Paul, collecting the fish samples, and this was collected in Plaquemines Parish. So we look at the PAHs in the tissues we collected in Plaquemines Parish. We collected shrimp near the mouth of Bayou Jacks, naphthalene again in the shrimp. Oysters, the Gulf of Mexico, south of the mouth of Pasalute, phenanthrene and anthracene. The crabs, the Gulf of Mexico shoreline by Red Pass, naphthalene. The East Bay, naphthalene in the crabs. When we look at the Plaquemines Parish mussels, small island near the mouth, Pasalute, naphthalene, phenanthrene, and a 2-methyl. So you start to pick up mussels. Remember, we had the 2-methyl in the mussels in the other area. Redfish near the mouth of Bayou Jacks, the 2-methyl again. Mullets and the cut between Southwest Pass and East Bay. Boranthrene and phenanthrene. This is Paul collecting soil samples on the northern shore of Terrebonne Bay, just south of here. The PAHs in those samples and the oysters from Big Oyster Bayou, naphthalene, phenanthrene, pyrene. In the crab, we found a blue crab and a hermit crab, so we didn't have enough of either one, so we combined them into one sample, and it was the north end of Monaco Island, phenanthrene. Then we collected samples at Oyster Bay in August the 2nd of 2010, and again 1 year later, August the 2nd of 2011, trying to determine what has happened over that 1 year period to the area. On August the 2nd, the shore of the Gulf of Mexico, east of Oyster Bayou, where Atchafalaya Bay meets the Gulf, contained visibly oiled vegetation. Here you see the visibly oiled vegetation, and notice it's August the 2nd of 10. This is August the 2nd of 2011, no longer visible oil in the vegetation. But we're going to look at the soil sediment, and we're going to look at oysters. The soil sediment, August the 2nd of 10, hydrocarbons and carbon disulfide, that's a sulfur compound. Alkylated PAHs, 6 of them, and you see the concentrations here. This is in the soil, near that visibly oiled vegetation. In 2011, the oil range organics were down to non-detect. The alkylated PAHs were down to 22.9. So what happened was the oil range organics went from a high number down to non-detect, and then the PAH that was there decreased from 29.3 to 22.9, but it's still there with a slight decrease in the soil sediment samples. And they went in January and collected in that same location again as part of GC-HARMS, and then we'll go back out in the next year, August the 2nd of 2012, and collect samples so we can track it over an annual basis. So when we looked at the oyster samples from the Oyster Bayou Reef in August the 2nd of 2010, we had petroleum hydrocarbons 8,815, and we had non-detect in the alkylated PAHs. We went back a year later, petroleum hydrocarbons 113 milligrams per kilogram, but look at all the PAHs that are now in the oysters in that same location. They bioaccumulated. Oysters are filter feeders, and they were picking up the contaminants and taking them into their bodies. So the petroleum hydrocarbons in the oysters decreased from 8,815 down to 113 milligrams per kilogram in that 1 year period. The alkylated PAHs increased from non-detect to a concentration with a whole host of PAHs. Bioaccumulating, and John will talk a little bit about that. So the tissue sample data indicates contamination of aquatic tissue samples were the components of the BP crude oil that was spilled by the Macondo well. And the results of these tissue samples and analysis over the time indicates the necessity of tracking the contaminants over a long period of time. So UTMB took what we had done, the results we had, and put together their program to track it over a long period of time. And so now John will tell you specifically about their phase of the project, building off of what we had done to this point.
Does anyone have any questions about what Wilma was talking about?
George, why y'all talking about Atchafalaya? Because I seen Jeroboam B. George, why y'all taking all the time? George, why you taking all the time? As by Atchafalaya B or here Jeroboam B? Jeroboam B or why?
No, it's not the one. It's not the one in Terrible.
So Oyster Bayou they're talking about is not in Terrebonne Parish. It's in Atchafalaya somewhere.